lesson lo, if you throw a body up with 10 meter per second, if you throw a body with 10 meter per second, let's say it is 5 kg. Let's say it is 5 kg. First lesson lo, what do we do, ma? It's motion in one dimension, correct or not? Either we'll throw them up or either we'll make them move horizontally, correct or not? Only two cases. Next we'll have projectile motion, mostly in a plane. In all these cases, you can calculate change in momentum. Okay. What is the initial momentum of the body? What is the initial momentum of the body? 5 into 10, which is 50. If you want to write it as vector, what will you do? If you want to write it as a vector, you can keep j cap, no problem. Okay. But since motion is along only y direction, so we don't have to write I cap, j cap sometimes. Why I am saying that means in textbook sometimes they will not mention j cap, so don't get confused. When will if we throw up, what will happen to the body? What will happen to the body? Tell ma, come on ma. You know, first lesson question if you don't answer, come on. What will happen to the body? We throw up. I told you motion, you should be very clear. Come on. What is the only force will be acting on the body?
Gravitational force.
Gravity downwards. So what will happen? Just describe the motion. What will happen?
Body will go upwards initially and then come back down.
Yeah, no. Better motion wise.
It will decelerate when going up and accelerate.
Yeah, I told no, it won't be moving with constant velocity. What happens? Whenever I ask motion of the object, you should be able to tell whether it is rest or constant velocity, or it accelerates or it decelerates. That's what you should tell. Okay. So what happens? My decelerates, correct or not? Constant deceleration or variable deceleration? Constant, because gravity is constant, correct? So what happens to 10 meter per second? What happens to 10 meter per second, ma? Deceleration, if you use sophisticated word, you know, deceleration means what? What happens to 10 meter per second?
It decreases.
It decreases, correct or not? 10 will become 9, 9 will become 8, 8 will become 7. Like that, at highest point, what happens?
Velocity becomes zero.
Point, it will become 0, correct or not? So if somebody asks what is the change in momentum for upward journey, what will you do? What will you do, ma? What is change in momentum for upward journey? What is change in momentum for upward journey?
Minus 50.
Minus 50. P final minus P initial. What is final momentum?
0.
0, because velocity becomes 0, right? Mass will be like that only. Velocity becomes 0. What is initial momentum? 50. So it will take minus 50. If you want to mention direction, what will you write? Change in momentum is minus 50 j cap, correct or not? J cap will come. J cap extra will be there. That's clear or not? Understood? This is upward journey. For total journey, what is the change in momentum? Total journey, what is the change in momentum? That means it will come back to your hand, ma. For total journey, what is the change in momentum?
0.
How?
Because it's returning to the same place. Awesome.
What is change in momentum for total journey?
When body is coming down, it accelerates, so the momentum increases.
Didn't get you. What?
Since the body accelerates while coming down, the momentum increases and it becomes the same while coming down.
Becomes the same when it reaches the hand, correct or not? Okay, fine. So change in momentum is how much?
0.
0 is wrong. That's where you should be careful. It's a vector. That's why you have to be careful. Understood or not? Anybody will tell 0 only. That you have to set it. Initial momentum is upwards or downwards?
Upwards.
Upwards, correct or not? P1 is P initial is 50 j cap, correct or not? It is going upward. Finally, when it is reaching your hand, it will have same velocity. That is the, unless air resistance is there, it will have same velocity, correct or not? That is what we did actually when we are doing first lesson. How much velocity you throw, same velocity it will reach in your hand. Okay. But it will be minus 50 j cap, no, because now it is coming downward, right? So change in momentum is not zero, ma. Change means what did I ask you to do? Change means what did I ask you? Don't add 50 j cap and minus 50 j cap. Don't add them. What you should do, ma?
Minus 50
P final
J cap
minus P initial. Then answer is
minus 100 J
j cap. If you don't want to tell j cap, you can tell simply magnitude is 100. Magnitude is 100 only, no, ma. Change in momentum magnitude is 100. Suppose this is the ground, ma. Okay, this is the ground, and you dropped a ball. Okay, you dropped a ball from certain height. You're standing. Okay. Drop the ball. Thinking to make the sum complicated. G. You put it from a height of 2 meters. Okay. But later on it jumped to 1 meter only. It jumped back to 1 meter only. Understood or not? From how much height you put it down? 2 meter. After hitting the ground, some balls will not rise to the same height, correct or not? Some balls will rise little less than the height you are putting. What about radium ball? Changing its momentum. Who is changing its momentum? It is going down, no, peacefully. Who changed its momentum?
The ground.
Ground, correct or not? So ground is applying some force on it, correct or not, ma? Ground is applying some force on it. How much force the ground has applied, we need to calculate. Understood or not? How much force ground has applied, we need to calculate. So according to force, what is the formula, ma? What is Newton's formula? Change in momentum by change in time. So you should know this time is, what is this time? This time is how much time it is in contact with the ground. It will be in contact with the ground, but not for long time, ma. Maybe 0.1 second, that's it, or not. Very less time it will be in contact. 0.1 second or 0.01 seconds it will be in contact. First important thing is you calculate change in momentum. After to calculate change in momentum. With how much momentum it is hitting the ground? Tell me, with how much momentum it is hitting the ground? What is the initial velocity of the ball? What is the initial velocity of the
2
ball?
meters per second.
No.
0.
Dropped, I told dropped, correct or not? That means it is 0, correct or not? Then, but it will attain velocity once it reach
The ground.
ground, correct? How much velocity it will attain? Velocity it will attain by reaching the ground. What formula we should use, ma?
V square equal to square minus
Square
2.
minus a square equal to 2as, correct? So how much? V square minus 0 square equal to 2 into 10 into 2 into 10 into 2 meters. How much more velocity?
40 meter per second.
Root 40, correct? So 2 root 10 meter per second. This is the velocity with which it is hitting the ground. With what velocity it is rising up? What velocity it is rising up? With what velocity it is rising up? How to calculate that? Again, equations of motion only. With what velocity it is rising up? Again, equations of motion. Shell. What velocity is it rising up?
Minus root 20.
No. It won't be because it is dropped from how much height? 2 meter, right? If it goes to 2 meter height again, then we can say it is minus 2 root 10. But it is going up to 1 meter only. That means it is bouncing back with less velocity. It is bouncing back with less velocity now. Tell. It is bouncing back with less velocity. So how to calculate that velocity? Again, equations of motion. Again, equations of motion we should use. Well, what is the formula? Again, we can minus u square equal to 2as, correct or not? But what is final velocity now?
0.
Final velocity is 0, ma. Final velocity is 0. Initial velocity is? Initial velocity we have to calculate. Initial velocity you have to calculate 2 into g value is 10, s value is 1 meter. And acceleration will be negative. Why? Acceleration will be negative more because body is traveling
Upwards.
upwards. So u equal to root 20. Clear or not more? Now tell, what is the momentum before hitting the ground? What is the momentum before hitting the ground? Pi is how much? What is the momentum before hitting the ground? Just before hitting the ground, what is the momentum? Just before hitting the ground, what is the momentum?
4 root 10.
2 into root 40 we got, correct or not, ma? 2 root 40, how to take? Can I take minus j cap, or you can put, or if you don't want to write vectors, you will put momentum is downwards if you don't want to write j caps. Final momentum after hitting ground. After hitting ground, ma.
2 root 20.
2 into root 20. Now it is upwards, correct or not? Now momentum is upwards. After hitting the ground, it is traveling upward. Momentum is upward. First one is downward, later one is upward. So change in momentum. Change in momentum. Change in momentum, how much more? One upward, one downward. If you add, what will happen? You have to add them, correct or not? Because they're in opposite direction and I'm asking change, I'm asking change. I'm asking you to subtract. So P final. One of them you have to take positive, another one you have to take it as negative. Okay, if you take upward as final direction as positive or initial direction as positive, anything you can take. So basically it will become 2 root 40 minus of minus 2 root 20 because one is upward, other one is downward. So 2 root 40 plus 2 root 20. 2 root 40 plus 2 root 20. I should do. How much force is applied by the ground means what you should do.
Divide change in momentum with
Divide change in
0.1.
momentum with the
0.1.
Yeah, change in momentum with 0.1. If they will give you contact time, how much it is there, they will give contact time, they'll mention. This much time it is in contact with the ground. It will be very small time, 0.01 second, 0.1 second, like that. Any doubt you can ask me. That's why, see, now on, I told you many times, previous lessons concepts will come, now also it will come, it will keep on coming. We can't change those things. It will be there all the time. Please be perfect. Now let's take projectile motion. Let's take projectile motion. A body is thrown. This is the ground, ma. This is the ground. A body is thrown from here. Again, let's take 5 kg body with 10 meter per second, but at an angle, correct or not? Projectile motion means I should throw it an angle, correct? Okay. Same things we are doing, ma, but extra we are multiplying mass, that's it. No difference in the question. Finally, it will reach the ground, right? Finally, it will reach the ground. Same like vertically thrown body. By the time it reaches ground, it will have velocity how much more? 10 meter per second, correct or not? With how much angle you throw, it will come same angle. But nadu in middle value will be changing. In middle value will be changing. Clear, mom? Now tell me what is the initial momentum? Initial momentum, how much? I want you to calculate. Question again, same question. What is the change in momentum of the body? What is the change in momentum? Same question again. No difference. Change in momentum I want. During this journey, what is the change in momentum? What is initial momentum? How much more? Initial momentum, how much? Tell the Tanush how to write initial momentum. This one already explained. No, body 1, body 2, body 3, body 4, body 5. How to write momentums?
Yes, sir.
Total momentum, how much? Tell this one alone. Momentum, how much? In this direction, momentum, how much total?
Sir,
Hmm.
50.
50, correct or not?
Yes,
But
sir.
I want to write it in terms of vectors. So what I should do? I should definitely do resolution, correct or not?
Yes, sir.
Tell. It'll have two components, do. Tell, do.
Yeah.
Are you perfect in writing
Horizontal,
components or not?
it's,
One is cos, one is sine. That's it. Simple.
yes, the horizontal component is 50
50
cos.
cos 30.
Yeah,
We'll write it as I cap because it is towards right.
yeah.
Hmm.
And 50 sin 30 j
50
cap.
sine 30 j cap. Understood or not, ma? Now here you should definitely see it's important to maintain I caps and j caps here, ma, because motion is along 2 dimension, correct or not? So if it is good if you maintain this. This is initial momentum. Initial momentum means what? The point where you use through the ball, okay, at an angle. Now tell me. Final momentum, how much? Final momentum. Aditya, Arpita. Final momentum, how much?
Sir,
Final momentum. I
in
told
terms
it
of
will have
vector,
same
sir,
speed. It will have same speed. But vectors you need, in terms of vectors you need to tell.
my minus 50 cos 30.
Angle we have to write, do properly.
And
So angle, how do we mark? Let's say this is this. How much angle it will make? Again with the horizontal only it will make. Again with horizontal only it will make 30 degrees. Okay, with horizontal it will make 30 degrees. Tell. With horizontal it will make 30 degrees.
oh wait, now it's just 50 cos 30 I cap
50 cos 30 I cap, ma.
minus 50 sin 30 j cap.
Minus 50 sin 30 j cap, correct or not, ma? Because component will come downward, correct or not, ma? That component, because where velocity direction will be like this, no, ma. See, that's why the drawing is important. Arrow mark is very important. This is the arrow mark. Then components will come I cap and minus j cap, because it is like if I tell in terms of north, south, east, west. It is in east-west direction, correct or not? Okay, Amma. See this, we have been doing right from relative velocity. We are doing same thing. Correct or not? Rain falling in certain direction, divide the, instead of velocity, we are dividing momentum. So what, mass? Same thing. No, we are just multiplying with mass. Correct or not? Same thing, velocity only we are doing. But we are doing with momentum. That's it. What is the change in momentum, ma? What is the change in momentum? Tell Marpita, what is the change in momentum? First, simplify this. Simplify them fast. How much?
The Pi is equal to
25 root
25
3 I cap
plus 25 j cap.
25 j cap. Down one.
25 root 3 I cap minus 25 j cap.
Change is how much more?
Sir, Pi minus Pi.
I cap you have to add. J cap you have to subtract. Not add, subtract. P final minus P initial ma. Change means. Subtract two vectors ma. Subtract the vectors. Still. Odd ma. 25 root 3 I cap, 25 root 3 I cap. What will happen, Arpita? Tell the Dhanush, what is the total change in momentum?
Sir, minus 50 j cap.
Minus 50 j cap. Correct or not, ma? So what do you observe? There is no change in momentum along. There is no change in momentum along what, ma? There is no change in momentum along what?
Horizontal direction.
Horizontal. That is what we learned in projectile motion. No, you remember? When change in momentum will come? When force is there, correct or not? Horizontally, any force is there? No force is. That's why momentum didn't change horizontally. Same point, ma. I'm putting in a different way. We discussed this point already, correct or not? I said horizontally constant velocity because no force in horizontal direction. Same thing I'm telling now also. No momentum change. Delta P0 means F will be. When force will come into picture, ma, momentum has to change, correct or not? Along x direction, momentum is not changing. That means there is no force in x direction. Along y momentum, along y direction, momentum is changing. Along y direction, momentum is changing. Because of which force, ma? Because of which force?
Gravitational force.
Because of gravitational force. Whatever topics we learned, in everything you can calculate change in momentum of the body at different intervals. Calculate initial velocity, calculate final velocity, subtract them. But we are multiplying with mass extra, that's it. That is what momentum means. You'll multiply with mass extra. Don't see them as a different things. What is change in momentum for upward journey? For upward journey, what is the change in momentum? Same question, write fast and go. Same question, come on. What is change in momentum for only upward journey? Upward journey means what? How much I gave? 5 kg, yeah? 5 kg and 10 meter per second. Upward journey means I want till here only, till here, till maximum weight. Till this. What is the change in momentum? This is initial position. This is initial. Let's say this is initial. This is final. There will be no change in which one, ma? There will be no change in. If you want to do fast, you know, when you are observing solutions, they will write equation fast. They will not write change in x because x will not change, correct or not? They will focus only on the y component. That's it. That much fast they will do. Yeah. If you want to learn slowly, no problem. Write down. What is initial momentum? Initial momentum.
50.
T
50 cos 30 I
cos
cap
30 I cap.
plus 50 sin 30 j cap.
50 sin 30 j cap.
What is final momentum? What is final momentum?
Zero.
No. If it is 0, it will fall down more. Forgot the concept.
At maximum height, the velocity will be 0.
No, no.
The
Go
ho-
back and revise. Go back and revise.
50 cos 30
Only
I cap.
vertical component
50
only
cos
is
30 I cap.
50 cos 30 will stay as it is, correct or not? At every point, horizontal will be 50 cos 30 only. Vertical component we are calculating different, correct or not? Vertical horizontal component will be there, or else it won't move further like this. It will fall down vertically down. There will be horizontal component. There is nobody to disturb. There is nobody in this motion. There is nobody to disturb horizontal component. Projectile motion, no one disturbs horizontal component unless you put some force along x direction. Unless you put some wind is coming in x direction, then horizontal component will get affected. Standard horizontal, so standard projectile motion, there is no disturbance to horizontal component because there is no force in that direction. What is the change in momentum? So if you want to do it fast, what you should do, ma? You should not worry about
Horizontal.
horizontal component, you can skip it and focus only on the vertical component. Here how much vertical component, there how much, so subtract, that's it, that is the answer. No need to worry about horizontal component. But fastness is required later on, slowly. When you become a little bit after first year, you should be very fast. How much my answer?
25, Jacob.
Minus 25. Change means we'll do always P final minus P initial. P final is 0, right? 0, P initial is vertical component, only vertical component. Horizontal component will get cancelled anyway. Clear ma? Any doubt ma? Momentum you will remember, right? Next class when you come again, I'll give you one momentum situation. You should calculate and tell me. Okay, yeah. When you will split it into vectors ma? When you will split it into components, it's neither horizontal nor vertical. Okay, but some cases what do we do? Some cases we split it along the motion, perpendicular to the motion. Some cases we'll take axis itself like this. This is x we say, this is y we say. We inclined axis itself. Like in inclined plane, correct or not? Inclined plane we change the rotation of axis itself like that. Okay. Fine. Remember and come. We'll do. It will be 2 more classes. It will be fine. Bye.